Okay, I mean, it's not adjusted yet, and yeah, we still have that shimmer we'll have to take care of, but look at this. Oh, dang it! Come on! Hello, and welcome to Game Revolutions, the series where I code up an arcade game using nothing but the 6809 instruction set, my precious Coco, and a little love. Today, I will be adding the ability for the car to shoot. But not just any kind of shooting, rapid fire shooting. I will be treating bullets as objects. That way, no matter how many bullets are flying through the air, the code remains the same. It sounds simple in theory, and it is simple. But that doesn't mean I got it right on the first try, or the fifth try. So I will be including a bunch of bugs for your amusement. Let's go! Here's a version of the original code that I wrote in high school. So you'll see there are some differences from what we have now versus what I had back then. There's no double buffering, so there's some tearing instead. And I can jump, but it doesn't look quite as good, and the reflectors, they don't continue while it's jumping. But check it out. I could shoot, but I could only shoot one pair of bullets at a time. And there were some special things that had to happen for that vertical bullet as it went up through the mountains. I did some really kind of crazy stuff so that it wouldn't rotate along with the mountains. I shouldn't have to do that anymore now that I'm redrawing the mountains from scratch each time. But what I sure would like to be able to do is let you do some rapid fire, so you could shoot more than just one pair of bullets at a time, because it's more fun that way. Back then it seemed super complicated to add multiple bullets at a time and have to check for each one if it's hitting anything. And the more bullets you added, it seemed like it would just get exponentially more complex. But what I didn't realize back then is that there is a simple trick you can employ to have as many bullets as you want and not to increase the complexity at all. And that is to treat the bullets like an object. So if each bullet had its own set of data associated with it, and then you kept around an array of all of those structures, and then you loop through that array, you just write the logic once, and it would apply to all the bullets in play. And more than that, at any point, you could take the number of bullets that you have, and you could change it to any number you like. If you want to have 8 bullets at a time, 20 bullets at a time, whatever. You just change the number, and the rest of the code stays the same. So here's what I wrote for the structure for each bullet. First, you have its type. If the type is 0, then that means this particular structure is not in use at all. And if the user wanted to create a new bullet, you can reuse that structure. Otherwise, it'll be either a horizontal bullet or a vertical bullet. As you saw before, you get horizontal bullets that shoot out of the right side of the car and go to the right side of the screen. And you've got vertical bullets that shoot out of the top of the car and go to the top of the screen. The offset tells you where the bullet is. The bit-seek index is helpful for masking and drawing the bullet. We're going to see that a bit later. But generally, this increases as time goes on so that you know what part of the byte to draw for the bullet. And finally, how close is this bullet to the end of its travel? This will keep counting down, and once it's off the screen, this will be 0, and then we'll be able to reuse this bullet info struct for later. While we maintain a global array of these bullet infos, there's another kind of structure that we use to help with drawing since we're doing double buffering. The buffer info struct, we've got one of these per buffers, and this is used to help one buffer remember the last thing that it drew. So each buffer will have its own set of a different kind of structure, a bullet draw info structure. Bullet draw info is much simpler. It just contains the address inside this buffer where the bullet is drawn and what the original 2 bytes were before we drew the bullet, so we know how to erase it. This structure is capable of doing both horizontal and vertical bullets, but to start with, we're just going to do horizontal bullets, one thing at a time. So I'm going to have each horizontal bullet, consist of 2 pixels. But keep in mind that each pixel takes up 2 bits. So in terms of bits, we're actually looking at this. So if we have our byte here, it might start off in the upper 4 bits. And then the 2 pixels might live right here. And then the 2 pixels might live right here. And then what happens next? Now I'm using up the low bits, but I still need a place to store that. So really, I need to use 2 bytes to represent the 2 pixels of the bullet because of this one point where it's straddling the lower 2 bits of the upper byte and then the upper 2 bits of the lower byte. The next point, it's all back onto 1 byte again, and I can represent it as I did before. So I'm representing the bullet as a series of masks and as a series of bits. So first let's talk about mask high, mask low. Since we've got 2 bytes, we're going to have 2 byte masks. So this is the high, and that's the low byte of the mask. The mask will have zeros wherever the bullet is supposed to be drawn, and it will have ones everywhere else. So if we look at the actual data for these structures, the high and low mask initially looks like this. So the zeros represent the 2 pixels of the bullet, so they're going to be in the upper bits of the upper byte. And then as it travels 1 pixel to the right, it will look like this. So those zeros have traveled 1 pixel to the right, which is 2 bits. Then they will have traveled to the low end of the upper byte. And finally, they will straddle the low end of the upper and the upper end of the lower. So that covers the mask. The bullet itself are the actual bits to draw the pixels for the bullet. So the bit sequence is going to be 1, 0 to get the color that I want. So the upper 2 pixels are going to be 10, 10, and then that 10, 10 just kind of travels through the upper byte, and then it straddles the upper byte and then the lower byte, and then we cycle back around to here. So let's check out some of the code that drives all of this. So this is the main loop, all the subroutines of the main loop. And just after we draw the car, we handle the bullets. And the first thing we do is we check to see if it's time to add another bullet. This is the assembly equivalent of the usual basic peak 65280. If this bit is 0 and what comes out is 65280, then that means the button is pushed on the joystick, and so we add some more bullets. This first block of code, just make sure that we don't add bullets too frequently. Right now I have it set to every 10 frames you can add a bullet, which is super fast. Any faster than this and bullets would basically be on top of each other. And then I check to see how many bullets are in play, and I double check that there's enough room for 1 more. Eventually I'm going to be checking if there's room for 2 more, because we're going to be adding a horizontal and vertical bullet, but right now just a horizontal bullet. And then here's where we add the new bullet structure. So we increment the bullet info count. We grab the current main loop counter, because we're using this to help keep track of when each bullet is added, so we don't add too many at a time. And then just a little bit of memory management. We go through our array of bullet info structs to find the first unused one. And once we find that unused bullet info struct, we initialize all those fields you saw, and a little note to eventually do the same for the vertical bullets. So back into the main part of the subroutine, after we have ensured that any new bullet info structures have been added, now it's time to loop through everything that we've drawn last time in this buffer and erase. We simply loop through everything in the bullet draw info structure array for this off-screen buffer. We grab the address where it was last drawn. We grab the original word of screen memory before we drew that bullet. And then we reapply that original word, thus erasing it. Finally, it's time to draw the new bullets. And again, it's just a loop. This time the loop goes through the global array of bullet infos, but at the same time we're going to have a pointer into the buffer local array of bullets drawn structures, because each time we draw a new bullet, we have to keep track in this buffer where it was drawn and what the original word was, so we can erase it next time. So for each bullet, we first check its type. If it's unused, we just go to the bottom of the loop and reiterate. If it's vertical, we're going to jump over here, although it ain't doing nothing yet. And for horizontal bullets, here's where we make use of that weird bit sequence index and those weird bit masks. Part of the bullet info struct is this bit seek index. That index traverses through this array of bit masks and bullet high and low bits. So we grab the correct row of this array so that we know the current mask high-low and current bullet high-low we're going to use. And first we take the original word in the screen and we're going to AND it with the mask. That will zero out the bits we want to draw the bullet in. So I grab my mask, I AND it with that byte out of the screen, and I do the same with the high mask. But after I mask each of the original screen bytes, I OR in the bytes for the bullet. So these are the bytes I'm ORing in, and you'll see there's 0 everywhere except where the bullet itself needs to be. So this is the only part that's going to have any effect. So after I've done that operation for both of the bytes, then I need to move this bullet to the right so that next time it'll be drawn in the new place. And that's simply a matter of advancing the bit seek index. So if the bit seek index were pointing here, next it'll point here. And if it were pointing here, next it'll point here. And if it were pointing here, then that means we're done with the bit sequence and we need to actually advance the address of the bullet. And that's all this code is doing. We advance the index by 4, and we compare to see if it's less than 16. If so, we're done, but if not, then we have to adjust the remaining travel so that we know when to make it go away. And we add 1 to the byte offset. So the 2 bytes that we're masking and drawing will advance 1 byte to the right. Okay, I'm sure this will crash and burn, but gotta run it and see where we're at. Fire! Okay, it didn't go very far. Motion is kind of smooth. Super slow! Alright, if I start here, does it... Yes, it does. Good. Fire... Oop. Oh, okay. So if I do more than 1 at a time, then that happens. Okay. Okay. Alright. I seem to have a lot of the same kinds of problems, don't I? Things never get erased quite right. Ugh. Fire, fire. Look at this. Like the first bullet just kind of expands. I'm going to try a couple things. First, I'm going to separate the bullets some more. So rather than every 10 frames, we'll have them go out every 16 frames. And also, since it seems to be going so slow, I'm going to do something a bit different here. Rather than having 4 elements in that bit sequence index, I'm only going to have 8 bytes worth, which is just 2 entries. So I'm actually going to comment out this and this. So now you're just going to see a bullet occupying the high 2 pixels, the low 2 pixels, and then that's it. And then it's just going to cycle back to the high 2 pixels of the next. So all of this careful work that I did to deal with straddling the byte boundary and moving only 1 pixel at a time, it's just so slow. I'm just going to go 2 pixels at a time. And finally, the bullet doesn't go very far. So I'm going to change this 7 to 15. Okay. Oh, jeez. Freak. Alright, everything's fine. I can shift. I can jump. I shoot. Oh, what the heck? Jeez. Well, if you were curious what the graphics screen looked like rendered in text mode, I could play the whole game like this. This would be fun. Alright, I think I found the issue. Okay, we can still move. I always like doing the things that I know work. Okay, shoot. Aha! And it's going faster. Okay, there we go. Can we do 2 at a time? 1, 2. It does start the new one immediately, but then the old one just stops getting... Okay. And look, it starts at the right place. Huh? A lot of things going right here. Something's going wrong. Don't worry about that. That's fine. Don't... Oh, weird. I think the bullet that I'm not seeing is still somehow Something's happening with... Okay, all right. Okay, I think I see the problem. So my Y register is pointing at the next bullet draw info structure to keep track of what needs to be erased. So I start my Y here, and I use my Y to do all of my bookkeeping. And when do I update my Y? Do I update my Y? Nope. I update my X. X is the global bullet info structures, but I never update my Y. I need to do some better bookkeeping, and also I need to remember things better. I'm bad at remembering things. Okay, now at the bottom of the loop, I have a couple places I might jump down to update variables. In the case where I actually did use up a bullet draw info because I drew a new bullet, I will jump down here to decrement the number of bullets in play, so I know how many more bullets to search for in the structure array, and also advance Y, and then advance X and do this other stuff. Okay, shoot. All right. Shoot, shoot. Ha ha! Ha 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 ha! Ha ha! Look at that go! Look at him go! Ooh! I'm seeing a little bit of artifacts of things there. Okay. I'll deal with that later. So, sine wave? Kind of like a sine wave? Kind of like a sine wave, maybe? That's pretty neat. Scoop them up. Scoop them up. See, can I scoop them up? Can I go faster? Oh, I should definitely not scoop them up. Okay. You know, it's not really good that the car can slide while it's driving faster than a bullet. These are still slow. They're still too slow. But maybe take a moment to recognize that it's not hanging and that I'm actually getting bullets going out there. You know, it's interesting that there's, even though now I'm skipping, rather than the bullets advancing by 1 byte, they're advancing by 1 pixel, they're advancing by 2 pixels. It's still pretty smooth. So maybe I shouldn't feel too bad about making it less smooth and just faster. The next couple of things I'm going to do is, first I'm going to simplify this. Now that I no longer have these two entries in the bullet bit sequence, I don't really need 2 bytes here. It's not like I have this middle of the road thing where I'm straddling the bytes. So I really only need a single byte to show what the bullet is doing. I only need a single mask. So I'm thinking something like this. Single byte for the mask, single byte for the bullet, and then it just looks like this. Bullet takes up the left 2 pixels. There they are. Bullet takes up the right 2 pixels, and there they are. And the other thing I'm going to try is down at the bottom of the main loop. As you may recall, I'm deliberately dropping frames to slow things down. So I'm doing this sync in a loop, and I'm running this 5 times. I can use some of these frames just for the bullet and nothing else. So I can have the bullet literally moving faster than the car is moving, than the mountains are moving, by dedicating frames just for the bullet. That's pretty fast. Holding it down, rapid fire. That's pretty good. You'll notice, by the way, if I'm very close to the right-hand side, it wraps around to the left. I think that will be automatically corrected when I go back to allowing the car to be slid only just so far. I'm only letting it go this far to make it easier to test things like the sliding itself. I think it's probably going to stop, well, I guess maybe stop around here. Might just be like this. But for now, and oh, okay, so it looks like the car still can be faster than the bullets. Yep. Let me see. Yeah, that's weird. That's weird. Okay. Still is looking better. All right, I think that looks better. They're not like clustering into a single line. And it makes sense they'd be bunched together closer as I'm moving. It's like the Doppler effect. Oh, nope, 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 nope. Darn it. Yeah, something, I think what might be happening is that as the bullet erases, it might think that it was on top of another bullet and it might be erasing it with that bullet color. I think that might be what I was seeing there. Maybe they need to be spread out a bit more. Might need to be some adjustments to do there. I have some more fit and finish to do for the horizontal bullets, but I've been getting a bit anxious to get some vertical bullets into this thing, so I decided to just plow ahead and added some code for vertical bullets. So here are just a couple places that needed to be changed. Every time we add a brand new bullet, this is the code you already saw. That'll make one horizontal bullet. And now it also makes one vertical bullet. Basically the same thing, except the type is different. The initial location is different. And that's it. And in the loop that draws the bullets, this was all the stuff for drawing the horizontal bullet. But if the type is vertical, then we branch over here to draw vertical, which is the new code. And the new code looks fairly similar to the old code, but it's much simpler to actually draw the vertical bullet because I'm simply drawing it as a single pixel. And that single pixel is always at the high portion of the byte just above the vertical gun coming out of the car. So all I really need to do is grab the byte on the screen. I remember it for later when it's time to erase it. And I just order the upper 2 bits to be 1. That should make it be a red pixel. And I store it back onto the screen. All right, place your bets. Is this going to work? Boop. Okay. It's not coming out of the right place. And a little bit of a shimmer there of green. That shouldn't have happened. If I rapid... Oh, no. Oh, no. Okay. Raise your hand if you didn't see that coming. Because you haven't been paying attention to how things go for me. All right, well, this was stupid. When I shoot, I'm now adding 2 more bullets in play. So we should really be adding 2 here, like that. This was probably affecting loops and going through all the loops and knowing how many to go through. Okay, I mean, it's not adjusted yet, and yeah, we still have that shimmer we'll have to take care of. But look at this. Oh, dang it! Come on! All right, how many of you saw it? Bambo! We are actually adding 2 bullets at a time, so we need to make sure we have room for 2 more bullets. So we need to compare against our max -2! Uh-huh. Rapid fire. Okay. Okay, cool. Cool. Now it does look like we got some shimmering up here sometimes with the lines of the mountains, and it seems to not go up very high. So there's definitely some extra work I need to do, but at least it's stable. So let's try jumping. Let's see just how stable it is. It's, uh-huh. It's okay. Oh, it's kind of okay. Yeah, whatever. This we can deal with. These are all little minor things. Okay, I've added a few tweaks, and in particular, when the bullet gets up into the mountain range, it should not be erasing itself at all, because the mountains redraw themselves every single frame. So the fact that they're redrawing themselves will do the equivalent of erasing the bullet, so I shouldn't try to figure out what were the colors behind the bullet, because the color is about to change, and they're also going to be erased anyway, so don't do that. Let's see what this looks like. What? Okay. 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 Actually, it looks like the shimmer's gone. So that's good. The shimmer's gone. So much better. It's like every bug kind of looks like it's a new kind of game. Can you imagine what game this might be? All right, I think I see what I did. This is kind of a common problem when I add more code and then I factor things differently and I branch around to different places. I may not be doing instructions at all the times that I should be doing them. I might be skipping over it at some points. So this adjustment here, which adjusts our pointer into the off-screen buffer where we're drawing by D, which is the offset where we need to be doing the bullet, this probably needs to be done in more places. So I'm moving this a bit higher into more common areas of the code. Okay. In some ways, these bugs are better than the game I'm trying to write. Okay. Lord. Okay, I went back. I did a lot of careful analysis of the code. I made several changes, several cleanups. Okay. Okay. Rapid fire, rapid fire. Okay. Oh, yes. There we go. So you'll see we still have the horizontal bullet wraparound, which I'm not going to care about. You might also notice that as it gets up here, the bullet there's this weird effect where it goes from 1 to like kind of 3 bullets. I've been debating what to do about that and what's causing that, and I've decided this is a natural effect of the refraction of the bullet through the atmosphere that we all know the moon has. The light through the moon atmosphere is causing that effect, and I need to leave it for proper realism. So that's what I'm gonna say about that. Because for crying out loud, can we please move on here? This is good. It's very good. Okay. Well, once again, I wish to thank everybody for watching. I hope you got entertainment out of my misery. And maybe we all learned a thing or two today. Next time, we gotta add something to shoot.